Okay, so in the next few lectures, I want to go more deeply into evaluating arguments. So we've already talked about distilling arguments, and I think that is a good first step to evaluating an argument, to seeing if you think it's a good one or a bad one, seeing where it might fail to be convincing or need more work, or even if it's a bad one where it goes wrong. But I want to delve more deeply into the form of arguments. And I think this is a good first step. Look, if you can look at the form of an argument and it's not a good form, then the premises don't really support the conclusion. You can kind of spare yourself all this effort of digging into the premises, right? If you're making an argument of your own, the first step is you want the form to be good, because if it's not, it won't work, right? Remember our metaphor of a building. If you don't have a good plan, nothing else matters. It's going to fall down, right? But before we can talk about the form of arguments, we need to think about how the premises can support the conclusion. And there are actually two different types of arguments. Some people have argued that there are more. I know, funny, right? Arguing about argument. Philosophers do that, right? It's unclear, but at the very least, there are two sorts of argument: deductive and inductive arguments. And the difference is important because in inductive arguments and in deductive arguments, the premises support the conclusion in different ways. And often a good step, in seeing whether an argument's convincing, first step will be, is it a deductive argument or an inductive one? So let's say a little bit about the two different types of argument. So the first pass here, and I'll go into more detail, I know this is a bit vague, deliberately so, but the first pass here is this. For a deductive argument, if the premises are true and the form of the argument is good, then the conclusion must be true as well. If the form is good in a deductive argument and the premises are true, the conclusion must be true. In fact, the conclusion cannot possibly be false. We'll talk about this in a minute. There is no way for a good deductive argument, or at least one where the form is right, that you can imagine the premises being true and the conclusion false. Now, this talk about the form of the argument being good is very vague. It is deliberately vague. I will say more in this lecture and in future lectures about what it is for the form of deductive arguments to be good. An inductive argument is different. If the premises are true and the form good, then the conclusion is likely to be true. No matter how good an inductive argument might be, all you can say is the conclusion is probably true. Now look, you don't want to undersell this. We'll talk about them in a second. In some cases, in very, very good inductive arguments, likely true might mean 99.999% chance of being true, which is a very good chance. The important point is there's at least a possibility the premises could be true and the conclusion false. All right, I think with this it'll help to give some examples, though. So here is an example of a deductive argument. This is the one, or at least one of the ones your reading uses. This is the classic one from every single logic textbook ever, right? All men are mortal means all men are going to die. Socrates is a man. By man, we mean human beings. So Socrates is mortal. Socrates will die, right? This is a deductive argument. If these premises are true, and they in fact are, we can't imagine any way the conclusion would be false. Here's another example of a deductive argument. Only people who are natural-born citizens of the U.S. are eligible to become president of the U.S. Anyone who was born in a foreign country and whose parents are not American citizens is not a natural born citizen. Arnold Schwarzenegger, the famous action movie actor, one-time governor of California. Arnold Schwarzenegger was born in a foreign country, Austria, and his parents are not American citizens. So Arnold is not a natural born citizen. Therefore, Arnold is not eligible to become president of the U.S., right? If these premises are true, and they in fact are, the conclusion must be true as well. Here is another example. We'll switch to inductive arguments now. Here's an example of an inductive argument. Not a great one, but not a terrible one either. I've met 5 students who all go to Hampton-Sydney. Hampton-Sydney's a college, and they're all men. So there are probably more male students at Hampton-Sydney than women, right? If you meet 5 random students and they're all men, it's a pretty good chance that shows there's a lot more men there than women. But maybe not, right? There just might be a weird process where there's just as many women or not more than men. You just happen to meet the men, right? If you guys know anything about Hampton-Sydney, it's actually one of the few all-men's colleges left. We're not interested in that here. We're just interested, well, how much support does this premise provide for this conclusion? Another example of an inductive argument. Numerous studies have found that smoking makes it more likely that one will develop cancer. Studies have also found that smokers are much more likely to develop emphysema. So if you keep smoking, you will probably develop health problems because of it, right? Even if the premises are true, and they are, the conclusion, there's a chance it's false, right? If you smoke, especially if you smoke heavily for a long time, all the evidence is that you are very likely to develop health problems. But there is at least a chance that you won't, right? So hopefully you guys get a sense of the distinction between the two kinds of arguments. If you guys remember high school geometry, or if you take future math classes that involve proofs, mathematics works on deductive arguments. All the arguments you're going to see in mathematics are deductive. The sciences, on the other hand, biology, medicine, social sciences, are almost entirely based on inductive arguments. So both types of argument have their place. We are going to focus on deductive arguments in this course. There's a few reasons for this. The biggest one is that moral claims, the general view on them is that moral claims are supposed to have validity in all cases, right? When I say murder is wrong, I don't mean, well, yeah, probably it's wrong to kill people for no good reason. I mean, it's always wrong to kill people for no good reason, right? So deductive reasoning seems to fit with the style of moral argument pretty well. That's the main reason, right? Mathematics uses deductive arguments, moral philosophy, even though we're not going to have quite the precision of math, deductive arguments seem to fit well with what we're trying to do too. The other reason is that it's much easier to evaluate deductive arguments than it is inductive ones. We'll talk about the reasons for that in a second, or at least in the next lecture. The main one is that inductive arguments, we'll talk about this concept of validity. Deductive arguments, it's a pretty 1 or 0, black or white, yes or no question whether they're valid. It doesn't come in degrees. Inductive arguments, on the other hand, there's not a sort of 1 or 0 binary, well, is it valid or is it not? Inductive arguments come in degrees of how convincing they are or aren't. That is much trickier to evaluate. Not only is it much trickier to evaluate, if you really get into it, it involves math. I know some of you guys would be excited if we got into math, some of you would be terrified, but it does make it more complicated. So look, be able to recognize inductive arguments when you see them. Don't, a very important thing is don't treat them like deductive arguments. They're not. But we're going to focus on deductive arguments in this course. So know what an inductive argument is, be able to spot it. We're going to focus much more on deductive arguments though.